All right, let's jump in. I think probably a lot of folks out there have seen me do keynotes or presentations before. My name is Matt MacPherson. I'm the Enterprise Networking Wireless CTO at Cisco. And my responsibility is multifold. I'm very much involved in regulatory. Of course, we sit on a lot of boards and lead a lot of work groups in the standards processes. But we're also responsible for looking at the next generation. Sometimes we call these disruptions, sometimes we call these trends. What's happening in the industry? And as we look at that, what do we have to handle not only on the networks today, but what are we going to have to handle in the near future? And so that's what I'm going to go ahead and get into today. Next slide. So I don't think this is any surprise to anybody. We are in a wireless first world. And although, maybe I'm a bit unusual because I'm working out of my home office today. And if I look over to my right, I've got a closet that's got a rack in it. And I've got a whole set of switches and, all this fun stuff that we like to do in our personal labs. But even so, I could run a cable over there and connect into my switch, but I don't because, frankly, we're wireless first. I'm coming in on a PC. This PC doesn't even come with a wired connection. In fact, all of my devices, that I'm using, these don't have wired connections. And so we're very much dependent on this next generation of connect everything reliably at scale, while offering security and keeping a what I would say a good quality of experience even while we're mobile. Now that's easy to say, but I know that there's a lot of you out there that are managing networks and have the typical challenges as these things grow. Sometimes not so easy to do. So what are some of these advancements? Next slide. And it really is everywhere. It doesn't matter if we're talking about education or public venues or hybrid workspaces. We all like to talk about the hybrid now post-COVID. Whether we're talking about healthcare, manufacturing, industrial, going into warehouses, the issues are really around capacity, being able to support high capacity at high density with the performance that's expected, and this new characteristic that people are caring more and more about, low latency. Next slide. So just to give you a little bit of a feel, this data is fairly fresh. Germany did a study that compared the growth of fixed connectivity to mobile connectivity. And so just to explain that, mobile is considered cellular. Fixed would be everything that's coming in off of, what they call it fixed because it's a fixed location. So it's assumed to be at a venue. It's assumed to be at the workplace. It's assumed to be at home. So what that means is it can be a combination of wired and wireless. Now, if you take that data and you look at how much is actually coming in through Wi-Fi, 92.3%, and again, this is the Germany study, of that data is coming in through a Wi-Fi network. Now, look at the trajectory there. We have the data through 2021. That is a pretty steep slope. So you can imagine, given those growth rates, just how much traffic we have to carry. Is Germany an exception or is it normal? Well, we went and looked at UK as well. I have some of the numbers for some of the other countries, including the United States, but this data was particularly fresh. So if you look at the UK, slightly different metric here. The Germany data was billions of gigabytes per year. In the lower right, what we're talking about is the typical amount of gigabytes that you would have per subscription. And you can see that is growing, almost matching that curve in Germany point by point. So look, we have new challenges. We have to carry more traffic. How are we going to do it with these new sets of applications? Next slide. So interestingly enough, this pertains, I think, to some of the tips that we just heard. At the top here, I just wanted to give a rounded out number because the UK data on that last slide was from last year. And literally, I think it was only a week, 2 weeks ago, the UK came out with their new data showing cellular and fixed volumes. And what's interesting here is that the fixed volumes are growing at 40% CAGR. So that's just another indication that this slope is pretty significant. And the cellular volumes, look, they're growing at 30% CAGR themselves. And so in order to address this, the market is opening up additional spectrum. Of course, in the United States, Brazil, Saudi Arabia, we have multiple different places that have opened up the full 1200 megahertz. In some other countries, they've opened up some of the lower bands and are still debating the upper bands. But why is this important? As I was hearing early, they were saying, the more common channel width is going to be 80 megahertz. Well, that's what we're assuming as well, because when we look at the current deployments out there today, and we talk about radio resource management and the channel reuse factor, what we're finding is that most of our customers' AP densities require a reuse factor of 6 to 12. If you're going into something that's very open, like a stadium, you might have more. So given those densities of deployments, you can see what was typical here from a 5 gigahertz standpoint. What we mean by manual versus auto is if someone's going in and they're manually setting the configuration, typically you have about 64% 40 megahertz channels. If you're doing it automatically, so you're turning on some of the more sophisticated RRM software, which most people are doing now, and in fact, it's getting better. I'll talk in a minute about AI RRM. We see it's about the same, it's about there around 60% using these 40 megahertz channels. And so if you look at 6 gigahertz and the current deployment densities, what this means is your reuse factor to match it is going to be in these 80 megahertz channels. And we anticipate that 60+% of the market out there will go to 80 megahertz channels. And it was interesting to hear some of the other reasons in these best practices earlier. On the right, and I know this is very small, the slides will be published, but I just wanted to make a couple of observations. One is the maximum data rate is not what needs to be solved anymore. I mean, I get so much throughput on my Wi-Fi. It's typically a backhaul issue that I'm running into, as opposed to the amount of bandwidth on the Wi-Fi. It's not typically the Wi-Fi restriction that's stopping some of these new applications, but we are seeing that we have to maximize the overall system throughput. And that means we have to be able to address density while maintaining those throughput characteristics. We have to be able to manage interference in order to get some of those low latency characteristics, which is really the next point. A lot of the work that's coming out of the standards these days is really about latency. And latency can be a tricky beast, especially in Wi-Fi. And we'll talk about some of the things that you can do to achieve these lower latencies, both on the spectrum side and from a stack perspective. But again, a lot of the features that are coming in Wi-Fi 6 with network scheduling, 6E to help us mitigate interference, 7 in order to drive up reliability and increase our overall throughput. A lot of these features are really around what we call determinism. Next slide. There's another megatrend, and you may have seen me use this slide before because I think it's quite relevant. That's happening in the industry is just around the number of devices that we have to connect into the network. So not only is the demand getting higher, and we saw that in some of those broadband curves, but the number of devices we have to connect to the network is getting higher and higher. And so we see that in this lower bar on the left, this light blue, that represents machine-to-machine communications. And the growth of that has moved from about 33% to 50% growth. What that means is that by this time next year, we're going to have as many things talking to things as people talking to people. And because of that, we have to be aware of what are some of the characteristics and requirements of those things. So first off, if a lot of things are connecting to the network, that means we have to share that bandwidth across the network. That means that if we're sharing across a much larger number of things, we have to schedule a much larger number of things. So how do we do things like maintain latency and throughput characteristics? How do we bound those things so we can still produce a good experience? And so you can see on the right that the growth in IoT or things, CAGR, is twice as high as the growth of devices in general that are going on the network. And so we're really designing networks for that next generation of things. and the characteristics that they require. Next slide. In fact, we did this. This is a survey that we did at Cisco Live just a few weeks back. We asked a lot of customers what their expectations were on the IoT devices that would be going into their network. And you see the two big bars here, somewhere between 1,000 and 10,000 devices. But the growth that they're seeing, when we ask them, where do you think this is going to be by 2025? They're saying this is going to be, up 100,000 devices, probably over 100,000 devices. And whether these are tags or we're tracking devices or we're tracking things, or we're adding new capabilities for automation, whether we're moving robots in warehouses, or we're talking about medical equipment in a hospital, many more of these things are going on the network and are expecting a good quality of service. Next slide. And sorry, this slide is very fresh, and so I kind of apologize for the roughness of the graphics here. We'll be cleaning these up in future presentations. But I thought it was very relevant. This also comes from a survey that we did while we were at Cisco Live and talking to many of our customers in what we call the Whisper Suite. We asked them, what is the IoT technology that you plan on using for connecting these things? What are you seeing out there, and what are you expecting it to connect to? And what we're finding is that almost all the connectivity is, first, unlicensed. Second, the most dominant technology out there for most of these customers' response is Wi-Fi. So the expectation is that these things are going to connect to Wi-Fi. Now, there's a bunch of 15.4 technologies, BLE, Zigbee, Thread, Matter. These are all based on 15.4, and we expect those to continue to serve in what I would call their specific use cases. It might be range, it might be lower bandwidth. There's other reasons for using some of these other types of technologies. But Wi-Fi has become the predominant one and where we're going to see most of that growth. Next slide. So where are we going? It wasn't that long ago. Wi-Fi was convenient. You may have heard me say this before. I can remember the first time I connected to a Wi-Fi network, and I thought it was super cool. I could go out on my back porch and connect over Wi-Fi and get my email. But when I really needed to buckle down and get work done, I either went into the office or I connected to a wire. But now we're in this wireless first. What do we mean? That means that we can do mission critical type applications, and we can do it at enterprise scale, and we can meet an enterprise class of service. And clearly we're there, and we've been doing these by design. And in fact, mostly how we've been doing this is by over provisioning and under subscribing. So what we do is we design the network to meet the current bandwidth and demands. And of course, when doing that, how do you squeak the most out of your spectrum? Well, you need to understand the lower layers. How do you understand the lower layers? It's using tools like Ekahau. Now, we're going into this new world of determinism. So how do we get into these new use cases where we need high reliability and bounded latency with the densities that we just saw and know that are going on the network? Next slide. So deterministic wireless, we try to put a simple way to describe this, because you talk to a lot of wireless engineers, and there's probably some of you on this call, but when you talk to wireless engineers, they say deterministic wireless, that's an oxymoron. You just don't know what the RF conditions are going to be. How can you get to determinism? So as everything is relative, we'll talk a little bit about what we mean by this. But as a high-level definition, what we're talking about is reliable communication while meeting application latency jitter requirements. Yeah, it's kind of like defining real time. A lot of times when you say that, oh, this system has to run in real time, what people mean is that it needs to be able to get its bandwidth through the network in a low time constraint. But what real time really means is fast enough. That you can get things through the network fast enough for that application. And so it's kind of the same thing here. How do we do reliable communication fast enough to meet the latency jitter requirements of the application that you're running? And those vary. Next slide. So two areas I like to talk about when we look at getting to deterministic wireless. One is what's the capability of the stack? And this is something that dramatically changed when we went into Wi-Fi 6. We went from OFDM to OFDMA. What that means is that we can schedule in the frequency domain. And by doing that, we can be far more efficient in how we're allocating resources to the multiple devices that are connecting into the network. It has to address scale. It has to be able to maintain latency when you're mobile. And so there's a lot of advancements that happen in the stack in order to meet this next generation of requirements. But the second one is really about interference. How do we control the collision domain? How do we control the experience over that interference when there's a bunch of rogues out there? What's the condition of the RF? What RF can we use? And as we go into 6 gigahertz and we get into things like AFC, where maybe we can use some of the channels, but not all of the channels, how do we manage that to the highest throughput? This interference domain is the, I was going to call it a playground, but I guess it's more serious than the playground, but this is the domain of Ekahau. This is what we're optimizing by using tools like Ekahau. And if we can address that interference domain and the stack capabilities to mitigate those things, then we can get to some of these deterministic results. Next slide. So we've done this. We're not just talking about this, we're doing this. This is happening in the standards, and this is happening with some of the partnerships that we have. This is an example of a technology that's available. I didn't get that. The internet isn't reachable. Oh, sorry about that. I think Alexa just thought I asked it a question. So this is something that's available now. What we've done is we've worked with Apple so that when the network is scheduling devices, it can do so more intelligently. Oftentimes, what happens in a network is that it tries to schedule the different devices in a fair approach. One of the things that we've recognized in enterprise environments is that you don't always want to be fair. In fact, you probably don't. There's certain applications and services that you want to prioritize, that you want to be able to maintain that bounded latency. And so by doing this communication between the device and the network, what we're doing is we're connecting the upper stack policy to the lower stack scheduler. So now if an Apple device tells us, hey, we need to be serviced at this rate for the applications that we're running, then the scheduling algorithm can take that into account and make sure it's scheduling that device at that frequency, for that bandwidth. Now, this was so successful, it is actually part of the Wi-Fi 7 specification. And the end result, just even for what we would call our traditional killer app, which is voice, we saw under heavy load over 40% improvements in mean opinion scores for connectivity. So these types of things can really improve the overall experience, even at density. Next slide. So what's coming? We talk about Wi-Fi 7. We know that Wi-Fi 7 is not that far off. We know that Wi-Fi 7 is going to really capitalize on the new spectrum. We see these additional services. And again, I could talk about the myriad of features that are going into Wi-Fi 7. But what I really wanted to point out is a couple of the features that are being really focused on this deterministic type capability. One of those is MLD or MLO, this multi-link device, multi-link operation, with the idea that you can connect into the network twice using multiple radios at different frequencies. And if you do that, you can configure that a couple of different ways. You can configure it so that you're getting more throughput, or you can configure that so that you have a redundant connection. That means that if you have interference in one piece of spectrum, you can maintain your connection over the other piece of spectrum, and then that interfered channel can be moved to another channel so that you can rebuild up your redundancy again. So instead of having this characteristic where interference comes up and things like latency just go out of control, what we can do is we can maintain that latency even as we're hunting around for the appropriate channels to use while connecting into the network. How we do that across the network is what we're talking about in MAP-C, or multi-AP coordination, which is now a Wi-Fi 8 feature. And I talk about it now because actually some of these capabilities can be done in software. So it's definitely something that's going to be standardized in Wi-Fi 8, but perhaps it could be available sooner. And then the other feature we talk about is SLA, or this SLA-based Wi-Fi. Next slide. So let's talk a little bit about SLA. So we just talked about these different technologies that are happening in the standards. and that are happening as we move forward, as we go into Wi-Fi 7 and 8. And so what does that actually mean to the overall performance? And again, one of the key things that we're focusing in here is on latency, because a lot of our bandwidth requirements are currently, it's hard to say that they're good enough, because, look, I showed you a slope that was going off the chart as far as additional bandwidth, but I think that that's sort of an expectation. But in this next generation, latency is becoming more important. So if we look at the light blue, that's the distribution of latency on a channel that's 80% utilized, where we have multiple devices, and those devices are trying to communicate at the same time. And you can see here that most of the time, even in these conditions, you can actually get pretty low latency, but all the way over to the right, and that represents somewhere around 7% of the time, you're getting these 100+ millisecond latency characteristics. And as we're looking at this next generation of applications and services, that's just not good enough. And I kind of call it the perfect storm, when for some reason things timing wise all are trying to transmit at the same time, and you're colliding and you're backing off. That's what's happening in Wi-Fi 5. Now, if we add Wi-Fi 6, because it's scheduled from the network, just that feature alone can actually achieve a bounded latency, maximum 100 milliseconds, typically, closer to 25. You turn on something intelligent like FastLane Plus, again, going into Wi-Fi 7, and now we can start bounding latency to 10 to 25 milliseconds. And if we turn on SLAW or SLA-based Wi-Fi, which is using wireless TSN functionality, now what we can do is we can start pushing latencies into the domain of this new world of low latency expectations, 1 to 10 milliseconds. And we've even got some things on the drawing board to get that down to 1 millisecond. So this is a phenomenal change that's happening with some of these capabilities. Next slide. So here's an example. I love this example, so you may have seen me present it before, but this is something that we did with Intel using this time-sensitive network capability, or what we're calling SLAW, where a Intel engineer has a glove on, and it's got a metal point for each of his fingers and thumb, and a bigger one for his hand. There's cameras in the corners of this room. The cameras are picking up his glove and how he's moving his hand, translating that motion into commands over to that robot arm. And as he moves his hand around, that robot arm has to mimic him. Why does it need to be real time? Well, because if it's not real time, then the robot arm will get disoriented and will eventually end up in a different place over the table than his hand is. And if he's moving around and he's reaching down to pick up that ball, and you don't have a real-time characteristic, a low latency characteristic, then when he stops his hand to pick up that ball, that robot arm could keep moving and actually damage the ball. So this is something that we know that we need to do in these environments using TSN and Wi-Fi 6. We were able to bound the latency to sub 2 milliseconds to meet the requirements of this type of application, which you would, I think, immediately recognize as something that would be necessary in a manufacturing environment or a warehouse environment or even in healthcare. Next slide. So deterministic Wi-Fi, what's it turning into? It's turning into automation. You see here some of the robots running around a factory. It's enabling the next generation of digital immersion. And I'll talk a little bit more about that as we simplify the way we do augmented and mixed reality. And it enables us to do these things at enterprise scale, connecting large numbers of people and things into this next generation work experience. Next slide. So just as an example, and you see some of the use cases in the pictures, but to get an idea of how fast this market is moving, the enterprise XR market in 2021 was about 28 billion. It is anticipated to be by 2028, 252 billion. That's just 7 years. So 7 years, 28 to 252 billion. And these investments are being made by some of the biggest names on the planet. NVIDIA, Microsoft. We see what Meta is doing. All the right now rumors around Apple, what Samsung is doing, big investments, big corporations for this next generation of digital immersion. Next slide. And so in looking at network architecture, what becomes very apparent is that there's two places that latency and jitter happen. One is when we go into the WAN or the SD-WAN, and one is over the air interface. For these types of applications, the switch fabric doesn't really inject concernable latency. And to get this next generation done in a way that's conducive to wearing these new devices on your body and the batteries lasting a long time, what you have to do is you have to reduce heat and weight. Those are the two biggest complaints of some of the big and the bulky headsets that you would use today. And so to get to something that's more like my pair of glasses, what's happening is that the GPU functionality, the CPU and GPU are being moved back into the network. In fact, some cases, even all the way out into the cloud. And Microsoft is already doing this. NVIDIA is already doing this. If you're a gamer, you've seen that this has exploded over the last few years. But what's happening is what's learned in that gaming industry is now being applied into the business community, into the enterprise, into public spaces, and into this personal digitization that we're talking about. And this is happening both in the enterprise or in the indoor venue, as well as around 5G access, so that you can move in and out of doors and continue that augmented experience, that digital experience wherever you are. And so you can see that if you start putting things like graphics processing that has to work in real time at 120 frames per second at high bandwidth into this headset, that's going to create huge demand on the next generation of networks. And it's going to have to work at scale, and it's going to have to work at low latency. Next slide. So a little bit, I'm going to shift gears a little bit here, talk about some practical AI applications. Next. So one of the things that we're very proud at Cisco about is that our end-to-end portfolio integrates analytics and the ability to collect analytics without impacting performance, what we would call end-to-end. We collect it from the AP or the cell, the switch fabric. We collect it from our policy engines. We collect it from what we're doing, of course, in our management platforms, and even we collect it from DNA spaces, which has to do with tracking things and people and the ability to offer services based on those capabilities. But there's always been this kind of line between what we're collecting from the network and what the device actually sees. And so what we've done with our partner ecosystem is we've extended the analytic capability to include what's actually happening in the environment. What's happening on that Apple device? What does that Samsung device see? We've done this with Intel chipsets. And of course, we've done it with Ekahau. Next slide. So if you look at some of the partners that we're working here, you can see the advanced partnerships. Of course, Ekahau is one of our key partners where we do a lot of joint work. We have a common vision on how to optimize these networks to address that interference in that spectrum domain, while at the same time pulling in analytics and capabilities from some of the partners you see here, both from a, I would call human digitization, smart device standpoint, but also some of the next generation of IoT devices that are also going on the network from those sets of manufacturers. Next slide. And so in doing this, when we talk about AI, AI is as good as your data lake. And so the more and the better data you have, the better you can apply AI to an improved result. And there's one of the key places that this has been happening over the years is our migration from statically assigning spectrum and power to your network to the traditional implementations of RRM where it does it automatically, to this next generation of what we call AI enhanced radio resource management. Next slide. And so this ability to adapt the parameters for optimization based on what's being learned the ability to pull in actionable insights to inform IT of what's going on in the network and actually see how it's being applied, and the ability to not only take a quick snapshot, but to then improve the RRM based on the current conditions of your network, the number of people that are there and how those people are migrating through that facility. Think of some place we do a lot of stadiums. We do Mobile World Congress Barcelona every year. The different shows that they have in there have different densities of people in different halls and different patterns of movement during keynotes, et cetera. The ability to actually modify RRM to meet the requirements of the time becomes very important. Now, how do we do that really well? Well, we do that by pulling in a lot of information from Ekahau so that we know what are the walls built of, how are the propagation characteristics moving through this venue, and pulling that right into our DNA center so that we can better see from a management and IT standpoint what's going on, even in real time. Next slide. I couldn't help but throw this in because I just thought it was so cool. This is a demo that we did at Cisco Live, and you can see there's an engineer on the left, and he's wearing augmented reality glasses. And so he looks through these glasses, and what does this do? It allows him to look at the ceiling or around the room, identify where the APs are, click on the AP, and then locate that AP on the map accurately. So where do you want to put APs? Well, Ekahau will tell you that. Are they in the right place? Using something like this would tell you right away if you're in the most optimal place for placing that AP and how that's configured. So this kind of shows a combination of using next generation technology a la XR and to be able to visually see what's going on in your network and place those APs. You wouldn't believe how many customers don't actually know where all their APs are. Well, maybe you would. I think there's a lot of customers on this call. Things get moved around for aesthetic reasons or whatever. This is a way that you can improve that overall experience. Next slide. So if there's one mantra I think that Ekahau and Cisco has in common, it's better Wi-Fi by design. And we really have a common goal here is how do we get the most out of the network? And this is why we work so hard with our partner Ekahau. This is why we're doing things like this seamless import of the Ekahau planning project files into DNAC, the ability to import the survey files, how we get the details that we do in populating 3D maps. In fact, this has been so productive for what we do between us. We not only use this at Cisco, but it's standardized for our deployments as we go into customer engagements. So, I'll just say that our experience is just really superb. I mean, there's very few tools on the market like the Sidekick 2, where you can calibrate so accurately that you could have multiple engineers going around the same facility and taking measurements without having to worry about calibration errors and getting misreadings between the devices. You might say that that's a simple thing, but it's not something that typical players do, but Ekahau does. If you got to walk an entire stadium, you probably want multiple engineers doing it. If you got to walk the entire 8 halls at Mobile World Congress, this is a bigger job than one person. So this is why I think our relationship with Ekahau is so is really important. And I just have 1 or 2 more slides, just real quick. If we go to the next one, we're committed to 6 gigahertz. Next slide. You may have heard that we've released and announced a lot of it at Cisco Live recently. A whole family of 6E devices for both indoor and outdoor and for hardened environments. And in fact, we've combined the capabilities of our Meraki solutions and our Catalyst solutions now into a common hardware AP platform that allows you to either go to the Meraki dashboard or to go to the DNAC on-site management capability. So 6E fully supported by Cisco, and I think takes us into the next generation. Next slide. This is the outdoor or hardened one that you would use in a manufacturing environment or a dirty environment. or if it's something that needs to be rained on, that does 6E as well. And with that, I think I'll wrap up.
Well, Matt, thank you so much. That was an amazing presentation. And I just want to say thank you so much. We know how busy you are. So being flexible with your time because of the technical issues that we had. So we just want to say a huge thank you. And also me personally, I love the new terminology SLAW. So I learned something new today as well. So SLA Wi-Fi is my new favorite acronym to start using.
That's how you refer to me, that I'm slow sometimes, right?
Actually, it means you're faster, but so.
Well, I definitely wouldn't be referring to Mac about that then. But Matt, again, thank you so much for your time and being flexible today. The presentation was so good, and we love the partnership between Ekahau and Cisco to drive home better Wi-Fi designs, to getting that great Wi-Fi every day. So